Okay, so let's look at this one. Let's just open it up in here. So we are defining what I call it, apply math exp or something like that. This guy is going to be a lambda. It takes in a math exp. Now this is a pre-parsed math expression. What's the advantage of expressions being parsed? Why is that helpful for us?
Tells you what comes next.
Okay. Well, I guess I expect. And this wasn't necessarily fully parsed. You know, I didn't parse these guys out, I guess, so you still had to check to see if those were numbers. But in any case, we add semantics to the elements so that we can just ask, what kind of animal are you, right? So when we go through this, we're going to have a cond. And this guy's going to do a whole bunch of math, right? We know it's going to be doing addition and subtraction. If we hit the empty list, what do we want to do? Maybe return a 0. Don't plus 0, minus 0, not going to hurt anything. So if null math exp boil down to 0, okay? Otherwise, if the car, say EQV car math expression is add exp, it's one of those guys, then we know it's that type of expression. And what follows a add exp math expression? Based on this example. 2 more math expressions. Okay, so we want to then call apply. We're going to be adding some stuff, so we're going to add apply math expression on the catter of math exp. So that's the first call to apply math expression. And then apply math expression on the CADDR math exp. And I'm going to actually kick this down just so you can see it all. All right, so if I'm looking at a add expression, do that. Add the result of apply math expression on the catter. That is the first element that's not add exp. And apply math expression on the CADDR, which is the second math expression. Otherwise, we might be looking at a what I call it, sub-expression, like that. What do we do in that case? We subtract apply math exp CADR math expression from apply math expression CADDR math exp. Otherwise, if I'm not looking at an empty list, and I'm not looking at a add expression, and I'm not looking at a sub expression, what must I be looking at? A number. What do I do with a number? Return it. So else, just boil down to that math expression. Something like that. And I guess if this was, let's call it fully parsed, this might have been maybe like a num3 and a num2, something like that. So the else would have been it must be a num. So boil down to the CADR of the math expression. Wouldn't have, that would be the only difference here, is this would be CADR of math EXP. Okay, questions on that one? Go ahead.
Shouldn't you never run into the null case?
Shouldn't I will not actually run into the null case in this because of the way it's written, so this is a waste of time. But if we ever did get in there, returning a 0 would be fine. Because and the reason is I always know I have exactly 2. So I'll never actually be passing it like the cooter of a list that has nothing in it. So what he's saying is that this is, I guess, for show. It certainly didn't hurt anything. I guess you could argue that maybe it does hurt something from the perspective of you would not get an error when maybe you should get an error if you created a incorrectly written math expression. So I guess if you want to be more correct, just take that line out. Okay, anything else? All right, so let's talk about the homework. The homework we were looking at kind of our expanded programming language, right? How'd the homework go? Feel like we're starting to get better at the stuff? Improvement-ish? Well, clearly this is a much bigger language now, right? But not necessarily a harder language, just more things in our cond. is what it comes down to, right? Each individual element really isn't all that bad. Now, I went off script on this homework, so what did I say? Write a parser for this guy? I don't think I said unparse, just parse, right? Okay. And then kind of take as, for clues, you can, I mean, if you really wanted to go super off script, you didn't have to name your thing a program, but it would have made sense to say that guy's a program. All right, follow-up question. On Android, when the, it happens with other things too, but like when the phone rings and it's giving me the little green thing and a little red thing to answer it, why can't I just hit the button? Why do I have to hit and drag?
Yeah, so you don't accidentally do it in your pocket or trying to get out of your pocket or something.
I have, I mean, there's this, what do they call it, butt dialing? I never did that with iPhone, but I don't think it's actually, I've dialed people accidentally, but through text messaging, because I think the default thing on the text message thing is if you swipe one direction, it's a call. Yeah, I probably need to take that off because I've done that multiple times. Yeah. I mean, have you been a long time Android user?
No, I switched from iPhone.
How long ago?
Like middle of last year.
Oh, yeah. So I'm a noob. I'm like a month in.
You'll still do it.
So in a decade, I didn't make one accidental phone call with an iPhone. I think I've made a minimum of 3 in like the last 3 weeks. So pretty interesting. Okay, and I also think I threw out there the caveat in here that since we're not using the built-in language stuff that's built into the language, we're not relying on their tokenizer for grabbing individual symbols outside of lists. So to allow us to keep focusing on what we're focusing on, convert things like our if expression into a list-based thing, which at the end of the day doesn't actually change what we're learning at all. It just makes us unreliant on the book's tokenizer for pulling out the individual pieces. Okay, so let's go ahead and write this, and we're going to call this guy, probably parse program? Let's look at this here real quick. So a program is an expression. Then we have an expression. So we really probably need 2 things to cover this. We need a parse program and a parse expression, where parse program is actually just a wrapper for parse expression. That just kind of throws the a program thing on there, right? So we'll start off by looking at this thing. So we'll go ahead and define parse program this guy will be a lambda that will take in a program as a parameter. And what we're going to do is we're going to return a list containing a program. And the next thing in that list will be the whatever's returned by parse expression on that program, right? Okay. So we'll go ahead and call parse expression on the program. So this is just us kind of marking up our top level expression as a program. If you didn't write this piece, that would probably be okay. Since we're not evaluating it. You should write it to give that final gift wrapping. But at the end of the day, this isn't doing much other than just marking the very top level. It would be just as easy just to assume that the top level is a program. Okay? So we'll go ahead and we'll write define parse expression. Now, you definitely should have written this guy. All right, so this guy is going to be a lambda that's going to take in an expression as a parameter. Now we got a whole bunch of different kinds of expressions. We got a number expression, we have a diff expression, we have a zero expression. All right, so let's just kind of go down the list here with our cond. So we're going to ask ourselves, if I'm looking at a number, that means it's a const expression. So here's our cond. So number exp boil down to list const practice. Nailed it. It's hard to, you don't know how far you have to swipe it. And then you might accidentally answer when you go the other way. You know, you might go, and all of a sudden I'm on the phone with my mom, which can last anywhere between a minute and an hour. Okay. Const expression, and then we're going to actually put the expression in there. So that's what we'll return if we're looking at a number, right? So if we're looking at a number, go ahead and mark it up as a const expression with the number, but we've encapsulated it in a list. Okay. If we are looking at a minus sign as the car, so let's look at all these other ones. We're going to have to separate these out a little bit because we aren't necessarily guaranteed to be looking at a, well, are we? This would be a list. This would actually end up being a list for us. This would be a list. We need to deal with the symbol one next because we aren't, at this point, we're not guaranteed to be looking at a list. This would be a list. So the next one we need to handle is this production right here to get rid of the two outliers, and everything else must be a list. All right, so symbol exp, we'll go ahead and create a list, and what does that call it? A var expression? Is that what they called it? Yep, var expression. Okay, so that's what we'll do for a symbol. Now we know we're dealing with a list as the rest of the stuff. So now we can start looking at the lists. All right, so our next dude would be a list whose car is a minus sign. Okay, so if EQV car exp minus sign, then I must be looking at a diff expression. And a diff expression is going to be a list whose first element will say diff expression, whose second element will be whatever parse expression returns for the catter of that guy, and whose third piece would be whatever parse expression returns for the CADDR of that guy, right? So this is a diff expression, so we'll create a list containing diff expression. Next element will be whatever parse expression. I'm going to go ahead and, well, let's see how long it ends up being, and then we'll kick it down. Parse expression returns for the CADR of expression, followed by whatever parse expression returns for the CADDR of expression. All right, so what I'm going to do is I'm actually going to kick. It looks a little funky, but it'll squeeze it in better. All right, so that's what we return if we're looking at a diff expression. A list containing diff expression followed by whatever parse expression returns for the CADR of that guy, and then followed by whatever parse expression returns for the CADDR of that guy. Make sense? All right, so that's that production. Next guy down the line, we're at the 0. So if the car is this word, 0 question mark, EQV car EXP is 0 question mark, then what do I call this? A 0 expression, 0 question mark expression. Then we're going to return. Now, this guy is a 0 followed by an expression. So this is going to be a list containing 0 EXP, like that. Is that how they named it? 0 question mark EXP. Followed by whatever parse expression returns for the CADR of the expression. All right, so we'll mark it up as being a 0 expression, and what are we representing? Whatever parse expression returns for the body of that guy. Okay, next, we are looking at an if expression. So if the car is an if, EQV. Now, I did have one student send me a question on Slack that is interesting to talk about it right now. I mean, if we were doing this in practice, are we missing out on some stuff here? What should, if this was a real life programming language, what should we be doing on top of what we're doing already? Or is what we're doing enough to parse a program? What assumption are we making? We're assuming the syntax is accurate, right? Now, I know that's a reasonable assumption if I'm writing the code. All my errors are all on purpose. Most programming languages will scream at us if we screw up, right? Okay. Ours won't. Ours just crashes. If you give us something we weren't expecting, we will just die a horrible, horrible death. So realistically speaking, and we did this several weeks ago, I think when we were first introducing something with parsers, I was going into a lot more detail for checking the individual components. So for example, in a diff expression here, we really want to make sure that they gave us exactly 3 pieces, right? You got the minus symbol, that's fine, that's fluff. Then you want to make sure there's 2 more parts and each one of those is an expression. So maybe we would have a predicate for expression question mark and toss it there, make sure it gives us back a true that the guy is an expression. So we don't try to parse something, it's not actually an expression. Kind of get what I'm saying? Now, we are not doing that because we're focusing on language constructs. Make sense? Error checking is super, super important in reality, but it would add a whole lot of bulk to our solution, so that's why we're not doing it. So I don't expect you to do it in your homework assignments, but I do want you to recognize that it's an important component. It would definitely be there in practice. All right, but right now we're kind of understanding how these things work under the hood. All right, so if the car, when I'm looking at the if one now, car EXP, if that guy is an if, then I'm going to go ahead and I'm going to create a list containing if expression. So now for an if expression, we're going to be following, we're going to have an expression. Now, you could have taken some leniences with this if you wanted to, because I kind of indicated that this guy would be, just listify all the stuff. I'll stay consistent here, and we're going to assume that the then and the else would all be included in our list. The only thing, if you decided to omit those, then you could, in fact, actually in the homework, didn't I give you an example of if? Where I maybe left those out, didn't I? Okay, yeah, so that's not very consistent to begin with, but whatever. So the only difference would be is how do you pick out the pieces? Is it the CADR or is it the CADAR, CADADR, that kind of stuff. But all right, so we'll do it leaving them out. So really an if would be if followed by an expression, that's the Boolean, followed by an expression, followed by another expression. Okay, but if you wanted to leave the then and the else in there for show, you would skip over those components of the list when you're calling parse expression because they're useless little tokens. All right, so if it's an if, I'm going to create a list that says if expression followed by whatever's returned by parse expression on the CADR of the expression. All right, so that is going to be this first expression piece here, that guy. Then, assuming you did not have a then in there, the next thing would be the CADDR. That's going to be our expression when things are true. Parse expression, CADDR expression. And then the last expression will be this guy. Assuming there's no else, it would be the CADDR. CADDR. Three Ds. Parse expression CADDR EXP. So that's what we'll return for an if expression. Else, car expression. We already did the symbol one, so now we're at this let one down here. If the car is a let, then we're going to be creating a let expression. In actuality now, since we do have to have an else, let's just throw that in the else. So our else is our let. So we'll create a list containing let exp. And then we're going to have an identifier equals an expression. Okay, so this guy becomes a little bit of an interesting thing. So maybe you represent this as maybe a to list. So we have a list containing the identifier portion of this, and then the expression that it's equal to. This is the local variable environment for this guy. So even if we leave the word in, where am I at here? Even if we leave the equal sign out of that in the implementation, if we say let A 5, we should create a list containing A and a 5 in it, a to list that has the name and the value. Except the 5 isn't necessarily a 5. The 5 is going to be whatever parse expression returns for that piece of it. Okay, but the variable name is going to be something that we're going to extract right now. So we'll go ahead and make a list here containing the CADR. That'll get us this identifier right here. CADR of EXP, followed by whatever parse expression returns for the CADDR of EXP. So that'll be that list. So that's the list that contains the name value pair right here. Then assuming we're leaving the word in out of here, this was the CADR, this is the CADDR, this is the CADDDR for the in. That's the body of the let. So this would be whatever parse expression returns for the CADDDR EXP. All right, so something along those lines. All right, so then if we write some examples of this, just to make sure our parser is giving us good stuff. If we go ahead and we write a, let's call this guy parse program, and we're going to pass it. Actually, let's go ahead and let's define a couple of programs. Define P1 to be a, we're going to create a bunch of expressions here. So let's start with a simple one. Let's just put a 5 in there. So there's our list const expression. Oh, hold on, let me get some of these other things out of there. And I don't want to call parse expression, I want to call parse program. Whatever, we'll just read the last line. So this guy gives us a list that is a program, and the program is going to be a list that's a constant expression 5. So good, so far so good. Go a little bit more difficult with this guy. Let's create this guy as an if. So let's say if 5, then we can say LOL zero 10. Something like that. So this would be a program that contains an if expression. The first expression of that guy is going to be a const expression 5, which we know isn't a Boolean expression, but we're not validating that at this point. Whose true expression will be a, what do we call it, a symbol expression or a var expression. So this guy is going to be the var expression, LOL. And then this guy will be the 0 expression containing the const expression 10. CADDR expects. I must have written this guy wrong, because we wouldn't have gotten into this. The car is 0 question mark. Because we failed out here in the else. I shouldn't have gotten to the else. So this is an if.
You remove the little apostrophe from the LOL.
Oh, we don't need that because this whole thing is quoted. So this isn't the symbol LOL. This is LOL inside of something that's quoted. So a program. It's an if expression whose Boolean expression is going to be our const expression 5, whose true expression is the var expression LOL, and whose false expression is a 0 expression of the const expression 10. All right, so let's assume we've tested this thing exhaustively. The hardest part right now is making sure we write accurate programs, syntax-wise, right? Okay, so that is, let's call it a reasonable parser for our language here. So now, what would make sense for the, well, let's just look at this last thing. So a constant expression makes sense in and of itself, right? It's just a number. So if I have a constant expression, a 5 boils down to a 5. What would we do with var expressions? Kind of take this a step further. Think about the quiz today where we're processing a parsed program. Where we're evaluating it, right? The book calls this apply whatever. So we would apply program here. If we applied a var expression, what are we actually doing to that guy?
Value in there?
Yeah, resolving that variable. Okay, so if I have a var expression, I need to go and look up the value for that variable. And What would that then require? How do I look up the value for a variable? It's the required component there for that. I need a variable environment, right? Okay, so now we're thinking about if we were writing apply EXP on this, or apply program on this, we're going to have to pass around that variable environment. So we're going to have to go and revisit our variable environment and think about the different scopes in which things get evaluated. Because you might have this global environment that has various scopes within it. Well, if this part of the code is evaluated, it's evaluated in terms of the variable scope that it had at that moment, not something that maybe gets added on later on. Perhaps like, for instance, in a let expression where we actually can create a new name value pair, that's going to be an augmented variable environment, right? Okay, so this guy's look up the difference. This diff expression, kind of a stupid thing, it's just subtraction, right? So I don't know, that just kind of goes off that homework assignment. But what would we do here? We would subtract the result of this guy from the result of this guy. The hope would be that we would have to validate those as being numeric const expressions at some point. But, you know, I guess whatever. The 0 guy, this is going to return, we would presume, a true or false because of the little question mark there. So the hope would be that the expression that's the body of that guy is something that we can test against 0 and ultimately give a true or false. Now, what are we really missing, though, in this example? Do we know that this guy is ultimately going to be a numeric? I mean, it really needs to be a numeric expression, right? Or at least something we can test against 0. Similarly, if we go to the if, this guy really needs to be a Boolean expression. But at this point, we don't have that additional clarification of what kind of expression you are. What is a Boolean expression? Any expression that boils down to a single value of true or false. What's an expression? One of these guys, right? By our current definition. And this guy doesn't have a component for a specialized type of expression called a Boolean expression. Does that make sense? So if we kind of keep thinking down the line here, things are going to, if we want to actually build this into a useful language, don't things get kind of more and more complex? Something as simple as that Boolean expression, which we use all over the place, really needs to be validated, right? A for loop, or a while loop, or a do while loop, or an if statement, none of those guys function at all without a Boolean expression. Well, we certainly can't compile or parse something unless we know how to detect if something is a Boolean expression. And how do we detect if something is a Boolean expression without actually evaluating the Boolean expression? Well, we have to look at the operators associated with the guy to see if those are operators that are compatible with producing a Boolean expression. Make some sense? All right, so that's kind of where we're going next with this. No class on Friday. We do have class Monday. No class next Wednesday, but I will be offering an extra credit opportunity for attending something with the Reformation Day events. So I'll put that up on Slack, so look out for that. I would look at the schedule. They send it out to everybody and plan on going to at least one of those events. Go ahead.
Does it have to be Dr. Loeffler's?
No, anything you want to go to. Yeah, I mean, I want to encourage you to partake in the Reformation Day events. I want you to go to it and get something out of it. So go to the sessions that you're interested in, but go to some sessions. Does that make sense? I'll put up the details for the extra credit up on Slack, probably sometime today or tomorrow. All right, questions, comments, concerns, bribes. Midterm is a week from this Friday, so we'll talk about it on Monday. All right.